Hey folks, thought we'd take a look at a trigonometric integral. The one I thought I would look at is the integral of cotangent to the fourth x dx. Before I get started on it, I'm going to write off to the right side here some things that I believe is going to help us as we try to attack this integral. The first thing is the Pythagorean identity that 1 plus cotangent squared. Well, we know that equals cosecant squared. And some other things that might be beneficial whenever I see a cotangent involved in an integration problem. Besides this identity popping into my head, just writing down or just knowing that the derivative of cotangent, I mean, we know what the derivative of cotangent is. It's negative cosecant squared. And we might as well go ahead. I don't know if we'll need it or not, but this pops into my head, the derivative of cosecant. So we know the derivative of cosecant is negative cosecant x cotangent x. So this is kind of like getting my weapons organized over here on the right side that I might need to use in attacking this problem. Okay, so now I begin the antiderivative of cotangent to the fourth by rewriting it as the antiderivative of cotangent squared times cotangent squared. And I'm going to use my identity, 1 plus cotangent squared is cosecant squared, to rewrite this as the antiderivative of cotangent squared x times the quantity cosecant squared x minus 1. And then if I go ahead and distribute that cotangent squared, I'm going to get the following. Better smack down a parenthesis. Cotangent squared x cosecant squared x minus the cotangent squared x. Okay, things are starting to come together for me because I see this beginnings. When I see the cotangent squared x cosecant squared x, I'm already kind of thinking a u sub for that. And that, if I let u equal cotangent, du is a negative cosecant squared. But I still have this pesky cotangent squared x that's cruising along here at the end. So I'm going to go ahead and use that identity, that Pythagorean identity again, to rewrite that cotangent squared x. So let me rewrite this one more time as cotangent squared x cosecant squared x minus. Now I'll use that identity and rewrite that cotangent squared as cosecant squared x minus 1. And if I go ahead and distribute that negative, I have cotangent squared x cosecant squared x minus cosecant squared x plus 1 dx. Or ripping it apart as 3 separate integrals gives me the antiderivative of cotangent squared cosecant squared minus the antiderivative of cosecant squared plus the antiderivative of, well, just a 1 dx. Now look how friendly those last two integrals are. We know the antiderivative of 1 is x. We should know the antiderivative of cosecant squared. We should know that's a negative cotangent. We get that for free from knowing the derivative of cotangent is negative cosecant squared. So the only integral that we really have to attack here is the first integral, the integral of cotangent squared x cosecant squared x, and that's easily taken care of by a u sub. If we just let u equal cotangent x, then du, well, we know du is a negative cosecant squared x dx. And then when we substitute in, we have the antiderivative of u squared. And that cosecant squared x dx, well, that's a negative du, so I'll put the negative sign out front. And, now it's just a matter of, well, it's a Nike problem. We're just going to do it. So let me scroll down, give a little bit more space for me. We get the negative 1/3 u cubed. And again, we know the antiderivative of cosecant squared is negative cotangent. So minus the negative gives us plus cotangent x. Antiderivative of 1 is x. tack on a plus c, resubstitute, and we get a negative 1/3 cotangent cubed x plus a cotangent x plus c. And that's it. That's our antiderivative. So I hope you found that to be a pretty friendly trigonometric integral to attack. Thanks for watching.